Alright, ladies and gentlemen, we're going to be discussing algebraic proof in section 2.6. Now, typically the way we start talking about algebraic proof is by listing properties that you have seen before. Every one of these properties was discussed probably in a pre-algebra environment in middle school, and also possibly in your Algebra 1 class. So the first four, the addition, subtraction, multiplication, and division properties of equalities, this is what we use in our everyday equation solving. These properties are what we use to say, all right, let's add 5 to both sides, let's subtract 10 from both sides, let's divide both sides by 6. So that's pretty much a step that gets used on a regular basis. Now the reflexive property of equality, I'll be honest with you. From an equality standpoint, we don't use it that often. However, we will be using the reflexive property a lot more. You're going to see it really when we get into chapter 4 more than anything else. So I'm not going to focus too much on that one right now. The symmetric property of equality, that's the one that when you're doing your work and you get something like 7 equals x and you say, I don't really like the way that looks, so I'm going to rewrite it as x equals 7, you're using the symmetric property. And the transitive property is kind of like the algebra equivalent of the law of syllogism. It lets you skip over the middle to go from the beginning to the end. So if I have A is equal to B and B is equal to C, B is linking A and C together, so why don't I just cut B out and say that A is equal to C? The substitution property, well, every single time that we take something out and we replace it with something else, we're using the substitution property. And of course, the distributive property we're very familiar with and we've seen before. Now, we've talked about proofs before, and we talked about a paragraph proof in the last section, and I told you that in my presentations we're going to see primarily two-column proofs. And honestly, the first way to look at a two-column proof is to actually look at what's called an algebraic proof, because that's something we can very easily understand. We know exactly what's going on with algebraic proof, because we're taking something that we've done many times before, hundreds, if not thousands of times, with equation solving, and now we're saying, okay, we're going to do exactly the same steps, but now we're going to tell you why we can do each step. That's the difference. Okay, so basically we're going to solve an equation, and we're going to justify each step. Now, we have to be given something in the beginning, and more often than not, in a proof, we like to use the word given, but since we're just solving an equation right now, we're not actually writing it in terms of a formal proof. We're just going to say, okay, that equation, well, that's our original equation. That's what we started with. So as we take a look at this, most people are going to say, all right, I see the distributive property. Let's distribute that 2. Let's distribute that -4. Remember to take the sign with that -4 when you multiply. And that would be what the next step looks like for a lot of people. And then the question is why? Why were we able to write that line? Well, what did we use to go from the first line to the second line? We used the distributive property because that's what we did. We distributed. Then somebody's going to look at that and they're going to say, well, we got to clean up. That -6a and that -4a, they go together. The 10 and the -28 go together, so let's clean it up. Now, there's no cleanup property, all right? There's no combining like terms property. So this is where some people get confused, but the more you use it, the easier it's going to be. Effectively, what you've done is you've taken the -6a and the -4a out, and you have replaced it with the -10a. The act of removing something and replacing it with something else is the substitution property. Now you're going to notice that little equal sign in parentheses, and the truth is when we have a property of equality, we put an equal sign. There are properties of congruence, which is, we would put a congruent sign if we were using those. And the reason for that is some of them, not all of them, some of them have the same names. So now I look at this and I go, well, I got to add 18 to both sides. So that's what I do. I add 18 to both sides. And what lets me add to both sides of the equation? Well, that's the addition property. And then I go, well, now I need to divide by -10. So that's what I do. And what lets me divide both sides by the same number? The division property. All right? This structure is almost identical to what we would call a two-column proof, which is what we're going to describe in the next one. Now, this one's a little different. This one's a little different because we're basically not just solving the equation. We're not getting t equal a number when we're done. We're basically saying, hey, we have a formula. And we don't like the way that formula is written. So I want to rewrite the formula to say something else. And they're flat out telling you what they want it to say. You're starting with that d equals 20t plus 5, And they're saying when you're done, it's going to look like t equals d minus 5 over 20. All right? Now remember, what a proof does is it tells you where you start, it tells you where you end up, and it's up to you to fill in the steps in between. All right? So that's what we're going to do. We're going to write a two-column proof. Now, in the classic structure of a two-column proof, and this is the way that I do my two-column proofs, and it might differ slightly from what you see in the book, the very first line of the proof is your given information. I like to include all my given information in one single line as opposed to trying to put it into multiple lines and splitting it up throughout the proof. All right? So when we make a two-column proof, we have two columns, hence the name, statement and reasons, and they are separated from each other. So the very first statement is your given information. Now for us, our given information was just that equation. And our reason for writing it down is, well, that's what they gave us. It's our given. So now it's time to do a little work. Well, somebody's going to say, well, I'm trying to get...
Mrs. Brennan, please dial star 500. Mrs. Brennan, please dial star 500.
Well, I'm sure you could hear the announcement. It's obvious I'm recording this at school. Let's continue from there. All right, so we have d minus 5 is equal to 20t. What did we do? We subtracted 5 from both sides. When we subtract the same number from both sides, what property is that? That is the subtraction property. Now, if I want to get t by itself, the next thing I should do is obviously divide. So I divide both sides by 20, and then we say, well, what lets us divide on both sides? That's the division property. Notice the, shortening because, well, let's be honest, we're lazy. We don't want to write more than we have to. The problem is they told us specifically we wanted it to say t equals, not equals t. Somebody's going to say, well, yeah, that's the same thing. Mathematically speaking, yes, it is the same thing. But in terms of the representation that we have in front of us, it's not what we want. They told us what we were supposed to have. We were supposed to have t equals, and the problem is I have equals t. So if this was an algebra class, you'd go, well, let's just flip it around. And you're exactly right. That's what we're going to do. We're going to flip it around. And the reason we're allowed to flip it around is because of the symmetric property. All right? So good structure for a two-column proof, very straightforward. Okay? Very similar to the previous example. And that's basically how we do it, how we get from one line to another. That's what a two-column proof is. It'll take time for everyone to get good at these. All right? The person who looks at it and just gets it from the beginning is very rare. Don't feel discouraged. Don't feel bad if you need explanation, if you need me to go over it when we're talking about the homework. That is pretty much everybody when they see proofs. And it's going to take longer for some people than others to get it. Some people are going to be really good at it in chapter 3. Some are going to take till chapter 4, chapter 5. Some people, well, you're going to have a hard time with it, all right? But the more you do, you will get better. I promise you that. And don't just say, well, forget it, I'm not going to do it, because then you're going to have you're going to have to struggle through pretty much the entirety of the course every single time we do a proof. You have to make that effort. Okay? These are pretty classic. Again, we learned these. Now, when you learned these, as well as that first table that we gave you, probably you were sitting in a middle school class and someone said, well, it's okay if you know how to use it. You don't really need to know what it's called. Well, guess what? Now you need to know what it's called. All right, so we've seen all these properties before. So let's look at something from a geometric standpoint. Now, solely in the interest of space, I can't really do my work on this slide, so we're going to move things to another slide. So notice there's no diagram. All it says to us is angle A is congruent to angle B, measure of angle B is 2 measure of angle C, and the measure of angle C is equal to 45, and they want you to prove that the measure of angle A is equal to 90. So we're going to basically create a nice little two-column environment. And don't forget the first line of our two-column proof. That's exactly what was on the last slide. No different. I just didn't really have the space to structure it properly. That's why it kind of disappeared for a second there. And our first reason is the given. Now notice I have all my information included on that line. Some people like to break it up. Some people would only write angle A is congruent to angle B. Some people would only write, measure of angle B is equal to 2 measure of angle C. I just like to list it all because once it's there, it's there. That's it. Now here's the problem. I have numbers. numbers work with equality. So when I have a statement of congruence, like angle A is congruent to angle B, I can't really use numbers. So I have to translate that. And we've said you can translate congruence to equality and equality to congruence. Just make sure, remember, it's not angle A is equal to angle B, it's measure of angle A is equal to measure of angle B. Now, the reason that I like to use for that is the definition of congruence. I've said it before, our book likes to be a little more specific, so they actually say the definition of congruent angles. Nothing wrong with that. Okay, nothing wrong with that at all. I would not be unhappy if I saw that. That's perfectly fine. So, okay, now I have measure of angle A equals measure of angle B. So now I have equality. And the next thing in my given says measure of angle B is equal to 2 measure of angle C. Well, if measure of angle A equals measure of angle B, I'm allowed to take measure of angle B out and put measure of angle A in. All right? Now, technically, this is the substitution property, but some people would make the argument that it is the transitive property as well. There are times when either one is an acceptable reason, but if you're not sure, if you say, well, it's substitution, but I'm not sure if I could say transitive, just say substitution. It's fine. I'd be happy if I saw substitution there. There's absolutely nothing wrong with it. All right? We could always make the argument that we went from measure of angle A to measure of angle B to 2 measure of angle C, and we skipped over the middle part, and that's why it's transitive. Or we could say, hey, we took measure of angle B out, put measure of angle A in. Okay? Well, the last thing that's in our given there is measure of angle C is equal to 45, so how about we plug in? Well, there's no plug-in property. When you take something out and you put something in its place, it's the substitution property. If we wanted to be technical, we wouldn't say let's plug in, we would say let's substitute in the value. So now let's actually just say, oh, it's 2 times 45. Well, 2 times 45 is 90. All right, now somebody wants to say, oh, multiplication property. No. Multiplication property is when you multiply both sides of the equal sign by the same number. No multiplication is taking place on the left side of the equal sign, so it is not the multiplication property. You are taking 2 times 45 out and putting 90 in its place. That is the substitution property. That is our lesson. If you need to go over anything, of course, when we go over it in class, we can discuss it. And if you have any questions, then of course ask. Your homework is of course listed on School Wires. And that's it. So good luck. Thanks. Enjoy.